Hey, Algebra 2 students. So today we're going to continue on in our trig unit and we're going to learn about our best friend when we talk about trig. And our new best friend is what we call the unit circle. So the unit circle has some key features that we need to talk about. And when I talk about the unit circle, the reason why we use the word unit is because it's literally like the size of one unit. We're using one unit, which means that our radius is 1. And that unit can be whatever unit you want. So the unit circle could be like 1 centimeter, 1 foot, 1 mile, whatever. But we just talk about it in general terms as one unit, so that way we can apply it to anything we want. So the unit circle has some key features. The unit circle has a radius of 1, so for that to happen, as you can see in my circle here, we have a radius of 1. The center will always be at the origin. So our center is at the origin, 0, 0. And then the unit circle, to have a radius of 1 means it's going to contain the point, or the circle is going to go through the point, 1, 0. It's also going to go through the point 0, 1, negative 1, 0, and 0, negative 1. So as it's easy to tell, the distance from the origin to 1, 0 is 1. So we have a radius of 1. The distance from here to here is 1. This is also a distance of 1, and so is this. So we can tell that our radius is 1 from the center of the circle to each of these 4 points. But because the radius is 1, we also know that, for example, the distance from the origin to this point would also be 1. The distance from this point to this point would also be 1. The center to this point on the circle would be 1. The center to this point on the circle is also 1. So those are just some key features of the unit circle. The radius is always going to be 1, and it's always going to contain these 4 points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So the first thing we're going to do with the unit circle is we are actually going to use it to expand our definitions and understandings of sine, cosine, and tangent. So to be able to use sine, cosine, and tangent, we need a right triangle. And one of the main things we use the unit circle for is, or one of the things that we apply to using the unit circle is right triangles. So we're going to be doing this a lot. So to be able to draw a triangle in the unit circle, the first thing we need to create is an angle. So we're just going to create an angle, a positive angle, like a general positive angle. To do that, we're going to put the initial side from the origin to the positive x-axis direction. And then remember, to do a positive angle, we need to go counterclockwise. So we're going to go counterclockwise and draw in a positive angle. And because we're talking about this angle in general terms, we're just going to call it theta. So we're going to talk about the angle theta. So now to complete the triangle, what we want to do is draw in, we're going to use this side here. So from the center to the point on the end of the circle, that's going to be the hypotenuse of our triangle. Then we want to create an altitude by expanding a side from this point down to the x-axis. And because that's the altitude of our triangle, we know that this is a right angle. So what we've created is a 90-degree right triangle that now we can apply sine, cosine, and tangent to. So we're still speaking in general terms. Because of that, I don't actually know what this point is just yet. I'm just going to label it as the point A, B, which means that the x value of this point is A, the y value of this point is B. Because the x value of this point is A, that tells me that this value on the x-axis has to be A, which means this distance here of this side of the triangle, the bottom side here, is A. Then if this distance, if this y value of this point is b, that means that this distance on the x value, right, or the y-axis, sorry, the distance on the x-axis, this would have to be b, which means that this whole side of this right triangle is distance b. So we've got a right triangle. It's got a hypotenuse, it's got side A and B, it's got an angle theta. Now, what else do we know about this triangle? We actually know the length of the hypotenuse, and the reason why we know that is because this is our unit circle. What was the radius of this unit circle? The radius was 1, right? Well, isn't the hypotenuse of this triangle the distance or the length from the center of the circle to a point on the edge of the circle? Well, that distance is a radius. And what's the radius of the circle? 1. So I know that the hypotenuse of this circle is 1. So let's go ahead and apply what we already know about sine, cosine, and tangent to this circle, or to this triangle, sorry. So what we know about sine, cosine, and tangent, SOHCAHTOA, is that the sine of an angle is equal to the opposite over hypotenuse. So in our case, the sine of theta is going to be equal to, well, theta is this angle here. So then that makes B the opposite side and A the adjacent side, or the attached side to the angle. So the sine of theta is the opposite, which is B, over the hypotenuse, which is 1. So that means the sine of theta is equal to B divided by 1, which is simply B. Okay. Now what about the cosine of theta? So the cosine of theta, from our understanding, is the cosine of an angle is equal to the length of the adjacent side divided by the hypotenuse. Well, the adjacent side of theta in our case is A divided by, and then the length of the hypotenuse is 1. Well, what's the cosine of theta then? What's A divided by 1? A. So what I would like to point out is that the sine of theta, and I'm going to use a highlighter here, the sine of theta is equal to B. The sine of theta is equal to B. Well, where else did we see B? Isn't B also the y coordinate of this point? And then if you look at the cosine of A, this says that the cosine of theta is equal to A. Well, isn't A also the x value of this point, where the point where the terminal side of our angle intersects with the circle? So what's interesting about this is that the sine of theta is really just the y value of this point of intersection. Sorry, that should have been in green. And the cosine of theta is really just equal to the x value of that point of intersection. So we're using our understanding of sine and cosine to actually further expand our definition. So what I'm saying is that the sine of theta is equal to the y value of the point of intersection between the terminal side excuse my sloppy writing, the terminal side of angle theta and the unit circle. So the sine of theta is actually equal to the y value of the point of intersection between the terminal side of the angle theta and the unit circle. So our terminal side of our angle theta is right here. This angle goes through here. And then our unit circle intersects that terminal side at this point, and the y value of that point, which we call b, is the exact same thing as the sine of theta. So the sine of theta is equal to the y value of that point of intersection, which means that the sine of theta is then equal to y. So let's go ahead and do our definition of the cosine of theta as well. So the cosine of theta is equal to, it's equal to a, and a was the x value of our point of intersection. So instead of the y value, it's the x value. So the cosine of theta is equal to the x value of the point of intersection between the terminal side of angle theta and the unit circle. So that means that the cosine of theta is really equal to x, the x value of that point of intersection. So if you know what this point is, if you know what these values are, then you know the sine and the cosine of theta. So then if the tangent of theta is really just equal to the sine of theta over the cosine of theta, then the tangent of theta is equal to y over x. So the y value divided by the x value. So you're going to use that information of sine, cosine, and tangent to help you with your homework. So on your assignment, you're going to be given a point. And in that point on the unit circle, you're going to need to tell me what the sine of this angle would be. So for example, if this was the angle, theta, you're going to tell me the sine of this angle, the cosine of the angle, and the tangent of angle by just using the x and y values of that point of intersection. All right, I'll talk to you guys soon.